Okay, let's try a couple problems. Let's look at number 2. The integral from 0 to 2 of x squared dx. Um, Beautiful. Part A, use the trapezoidal rule with n equals 4 to approximate the value of the integral. Part A, use trap with n equals 4. Okay, so let's go ahead and do that. Now, let me see, with n equals 4, so from 0 to 2, I want 4 sections here. So let me break it up. So there's my 1, 2, 3, 4. Now, so the change in x, delta x, will be 1 half. 1 half, 1 half, 1 to get me there. So 1, 1 half, 3 halves. Okay, so use the trapezoidal rule with n equals 4. So what is the trapezoidal rule? That is area equals change in x, 1 half over 2 times y once. We'll plug in 0 for x squared. Actually, I can just write that for now. 0 squared plus 2 times 1 half squared plus 2 times 1 squared plus 2 times 3 halves squared plus 2 squared. Okay, so there's my trapezoidal rule. I plugged in 0, 1 half, 1, 3 halves, and 2 into my equation, and I multiplied 2 in front of all the ones in the middle. Okay, well, 1 half divided by 2, that's going to be a fourth out front. 0 squared is 0. 1 half squared is 1/4 times 2 is 1 half. That'll just be 2. 3 halves squared, that'll be 9 over 4. That'll be 9 over 2 plus 4 at the end there. Okay, let me see here. 1 half and 9 halves is 10 halves. That's 5, 6, 7, 8, 9, 10, 11. So that'd be 11/4 for the area. Okay, that was part A. Use the trapezoidal method. B, use the concavity to predict whether it's going to be too high or too low. So B, what does concavity tell you? What does the concavity of this function tell you about the trapezoidal? Well, let's look at the 1 half. Okay, I'm sorry, 1 half. X squared. There's 2. There we go. There's my 4 sub-intervals. Because the concavity is positive, the line's always going to be above the function. So this is going to be an overestimate. So because it's concave up, it'll be an overestimate. If it was concave down, it'd be an underestimate. If it was half and half, it'd probably even out pretty well. Part C, find the integral's exact value to check your answer. So find the integral's exact value to check your answer. Exact value to check. So let's see. X squared from 0 to 2. That is going to be, what, x to the third, 1/3 x to the third, between 0 and 2. And we just need to evaluate it at 2, because the value of 0 will make it go away. So plug 2 in there, that's 8/3 minus 0. I went ahead and evaluated it at 0 anyway, equals 0. So 8/3. Okay, so the actual value is 8/3. The approximation I got was 11/4. Let me go ahead. What was that? That would be 2 3/4. That's exact. Sorry, 2 3/4. This would be 2 2/3. So yeah, 3/4 is a little bit more than 2/3. Okay, and in fact, for the calories I had to burn, this is much better. I was able to do this a lot quicker than I was able to use all those trapezoids and rules and whatnot. So this is actually burning calories. I don't need to burn, but except that they told me to do it, so I did it. I obey.